Hello and welcome to this lesson about writing parallel and perpendicular functions. The learning target for this video is writing functions that are parallel and perpendicular to other functions in slope-intercept form. First, I want to address what it means to be parallel and perpendicular algebraically. Okay, so geometrically, if we were to go to a coordinate plane, parallel means that two lines do not intersect. And unfortunately, I can't necessarily draw that, but you kind of get the idea here. These two lines would never intersect. Whereas if we're looking at perpendicular, again, on a coordinate plane, geometrically, they intersect to form a 90-degree angle. And so algebraically, we need to think about what this means. For parallel, what it means is that you have the same slope. So that's what we have to take away from that. That's easy enough. That kind of makes sense. Perpendicular, though, that's a little more complicated. And so you got to bear with me on this phrase here. You need the opposite reciprocal. Oops, ran out of room. Let's try that again. Down here. Reciprocal slope. So what does that mean? Oops. Let's say we had one line and its slope was 2. Well, if we want the line to be another line to be perpendicular, line number 2, its slope would have to be the opposite reciprocal. So first of all, opposite means different sign, so it's going to be negative, and it's going to be 1/2. Again, let's just kind of run through a few more numbers so you can kind of see it. So let's just say that the slope in line 1 was equal to 5/6. The slope in line 2 would have to be -6/5. If the slope in line 1 was equal to -1/4, the slope in the second line, to make it perpendicular, would have to be +4. So you have to take the reciprocal, you got to flip the numerator and denominator, and you have to change the sign. Whereas same slope, m1 is going to equal m2. So if m1 was equal to 2, m2 is also going to equal 2. So now let's take a look at what this looks like if we maybe are given a graph and a point. So let's say this is what we're given. They're given this line, this line, and then that point. And for our example purposes, we're going to do both. We're going to find parallel and perpendicular. Now the first thing I want to do is I need to identify the slope of the blue line. So I see an intercept here, and then I'm seeing a point right there. I also see another point right there, and it wouldn't really matter how I do it if I even went all the way from here to here. So let's see, I'm going up 6/4. My line is positive, so the slope is 6/4, which reduces down to 3/2. Okay, so if I want parallel, my m is going to equal 3/2. I then will use this point to find it. So we'll get 5 is equal to, -6, 3/2 times -6, we'll put that in for x, plus b. Keep in mind, we're still trying to do this in slope-intercept form. Y equals mx plus b. So we're going to use all this information that we have. We have an x and a y. We counted out the slope. We need to solve for b. Here, that gives us -3. So 5 is equal to -9 plus b. b would equal 14. So the equation, the function, is y equals 3/2x plus 14. And if we were to maybe, we wouldn't be able to see it because this graph doesn't go up to 14, but we could also just draw it out. We could go down 3/2, down 3/2, and slowly kind of draw out the line, and it would end up crossing up there at 14. So that's parallel. Let's talk about perpendicular. I just cleaned off the graph to make it a lot easier here. Okay, so we already know that the slope here is 3/2. Again, you got to count that out to kind of figure it out, to realize what it is. All right, so if we want perpendicular, what that means is we have to, I always like to write my first slope, so m1 equals 3/2. m2, which I'm going to use, is going to equal -2/3. I'm going to circle that and put it in my back pocket. Now I'll use the point, and just like I did with parallel, I'll do the exact same thing. 5 is equal to negative 2/3 times negative 6 plus b. Now, gotta watch out. We have two negatives here, so the negative 6 is going to go away, and it'll become just positive 2. The 3 completely disappears, and so we have 5 is equal to 4 plus b. Subtract 4 from both sides, b equals 1. We now have our slope, we have our intercept, y equals negative 2/3 x plus 1. And if we needed to, we could graph it. Put a point there. We know that this point, that the other point's on it. Connect them, and we're going to form that nice perpendicular crossing point right there. So that's how we do it from a graph. The other way you can do it is you can just be given the numbers. So, or odds are you're going to be given an equation. So it might be something like, here's the equation. Y is equal to 3/4 x plus 4. And we want you to find the equation that's parallel or perpendicular at the point 12, 0, or something like that. And so it's the same game. For parallel, we need to identify the slope first. So in this case, our m is going to be 3/4. And then you go 0 equals 3/4 times 12 plus b. Keep in mind at this point, this 4 means absolutely nothing to us. Continue to solve. So let's see here, that would be 3, and b would equal negative 9 when we subtract it over. So y equals 3/4 x minus 9. There's one equation. For perpendicular, I always like to identify the slope first. So m1 is equal to 3/4, meaning m2 has to equal negative 4/3. Plug in my points now. 0 equals negative 4/3 times 12 plus b. That's 4. I'll get 0 equals negative 16 plus b. So b equals 16. And then y equals negative 4/3 x plus 16. And that's how we would do it just from the raw numbers. So parallel and perpendicular, it's very similar to other problems you've had with finding or writing linear functions in slope-intercept form. The difference is you have to interpret the information in front of you. You have to be able to identify the slope from a given equation and then either know you have to keep it the same or find its opposite reciprocal. Good luck with your homework and practice, and let me know if you have any questions.